Alrighty, so this is our question. How many grams of oxygen can be produced from the decomposition of 100 grams of potassium chlorate, I believe? Yeah, potassium chlorate. Okay. So, this is a decomposition problem, and we're trying to find the grams of oxygen. So, oxygen is our target. So, let's write the formula for the decomposition of potassium chlorate. So the decomposition formula goes as such. So for 2 parts of potassium chlorate is going to decompose into 2 parts potassium chloride. Put the solid right here, and 3 parts of oxygen gas. So if you notice that we have a mole ratio of 2 to 3, or for every 2 parts of potassium chlorate, it's going to decompose into 3 parts oxygen, along with the 2 parts of potassium chloride, of course. But these 2 numbers are important for us finding out the mass of oxygen. So we're given 100 grams of potassium chlorate. So if you reference your periodic table, you'll find that the atomic mass of potassium chlorate is going to be 122.5 grams for every mole of potassium chlorate. So we have this part, so now we can knock the grams off from these. The units are going to cross off, and now we have to look at our mole ratio. So again, we've reinforced that there's going to be 3 parts of oxygen decomposed for every 2 parts of potassium chlorate. Because if we look at to ensure that this equation is balanced, let's look at the number of oxygen atoms on the left side. So we have O3, but 2 parts, so it's going to be 6 oxygen atoms. There's no oxygen atoms for potassium chloride, but there's 3 parts of O2, so 3 times 2, 6. So we can see that the 6 and 6 for oxygen, that adds up. Let's look at potassium, 2 parts of potassium, 2 parts of potassium. Is there potassium here? No, so we're good, we're balanced. 2 parts chloride, 2 parts chloride. Is there any chloride on the right side of over here? No. So we know our equation's balanced, and it's a proper equation. So what we're looking for is oxygen, so that's going to be our numerator, that's going to be our end result. So we have to keep this ratio of 3 parts. So for every 3 moles of oxygen, there are 3 moles of diatomic oxygen, there are 2 moles of potassium chlorate. That's awesome. So now we can knock these out, the moles of potassium chlorate. Those cancel out, numerator, denominator. So now all we're left is, we see that now we're left with the moles of oxygen. So how do we get to the mass? Well, we know that the molar mass of oxygen, of one oxygen atom, of oxygen is 16.0 grams per mole. And since we're dealing with diatomic oxygen, that's going to be 32 grams per mole. So let's go back here. So we have that. We're going to convert from moles to grams. So the moles is going to have to be in the denominator in this case. For 1 mole of diatomic oxygen, we're going to get 32 grams of diatomic oxygen. So now we can cross these out, and now our only unit that's left over, is grams of oxygen, which is exactly what we need. If we reference the question again, how many grams of oxygen? So this is perfect. So now what we're going to do is we're just going to do a bunch of number crunching here. So it's going to be 100 over 1 times 1 over 122.5 times 3 over 2 times 32 over 1. And this is going to give us our answer. This is going to give our answer in grams of oxygen. And let's look what we're dealing with. So we are going to assume 3 sig figs because this is 100 grams exactly of oxygen. So our answer is going to be rounded to 3 sig figs, 3 significant figures. So let's get our calculator out, type it in. So 100 divided by 122.5 times 3 over 2 times 32. And that's going to leave us with our final answer being 39.2 grams of oxygen. So there is our answer.